Example: a uniform rod AB of length A hangs with the one end A against a smooth vertical wall. A wall being supported by a string of length L attached to the other end of the rod to a point C of the wall vertically above A. Show that if the rod rests inclined at an angle theta to the wall, then the cos square theta equals to L square minus A square upon 3A square. What are the limits of the ratio of A is to L so that equilibrium may be possible? Solution: the rod is under action of three forces. The weight W acting vertically downward at the midpoint of AB, the reaction R at A, and the tension of T string BC. This is AB rod, this is the wall, and this is stringed CA of length L, and AR reactions. O is the midpoint, and at point G W is acting. This is angle theta, this is alpha, and this is alpha, and this is angle theta. In triangle ABC, CA is parallel to OG and O is the midpoint of CB. O is the midpoint of CB. Therefore, G is the midpoint of AB, and similarly G is the midpoint of AB. So OC equals to half, BC equals to L upon 2, and CA equals to 2 OG. In triangle AGO, A upon OG equals to A upon 2 cos theta, and AO equals to A upon 2 sin theta. In triangle AOC, OC square. In triangle AOC, OC square equals to CA square plus AO square, which implies OC square equals to 2OG whole square plus AO square, which implies L upon 2 whole square equals to 4 into A upon 2 cos theta whole square plus A upon 2 sin theta whole square, which implies L square upon 4 equals to A square cos square theta plus A square upon 4 into 1 minus cos square theta, which implies L square equals to 4A square cos square theta plus A square minus A square cos square theta, which implies L square minus A square equals to 3 cos square theta, which implies cos square theta equals to L square minus A square upon 3A square, which is proved. Now 0 is less than cos square theta is less than 1, which implies 0 is less than L square minus A square upon 3A square, which implies L square is greater than A square, and L square minus A square is less than 3A square, which implies L square is greater than A square, and L square is less than 4A square, which implies A square upon L square is less than 1, and a square upon L square is greater than 1 upon 4, which implies 1 upon 2 is less than a upon L, and a upon L is less than 1, so which implies 1 upon 2 is less than a upon L is less than 1.